Okay, Chapter 18, Calculate Superelevation and the Transitions. Let's go ahead and get started. Okay, the first thing that I like to do before I calculate my superelevations is I want to review my template, because the reason being, when I calculate superelevation and transition, it's going to look for points in my template. It's going to look for points in my template that are flagged to be a superelevation point. So I go to Template and go to Active Template here at the bottom left-hand corner. And then it's going to list for me superelevation points. So it's going to show me all points that are flagged for superelevation. And what would I expect here? What am I trying to accomplish? I'm trying to I'm not worried about rollover, nothing like that yet. I'm only worried about the top pavement itself. So really, if you think about it, I'm just worried about the edge of pavement, the center line, and the other edge of pavement. But when I looked in my list here, I noticed that if I open up this point here, the top of the ag base, notice it was flagged. And so why was it flagged? Well, the reason is we used IDOT standard components, right? And by default, they have it flagged or checked. And so, the reason might be because there are cases where all you have is the base. And yes, the base there's nothing on top to super elevate. There's no, say in this case, the county could come back later with an A3 surface or something like that. But part of this contract, we're just only putting down the base. So I don't know. So anyway, they made that assumption. But in this case, we do not want the top of the ag base to be flagged. So I unchecked it, click apply. And then if I look in my list, I notice that other one disappeared. So let me edit this other ag, the left side, the ag base. I'm going to uncheck that superelevation flag. And now my template should be good. So let's go ahead and save it. And then in the corridor file, still in the corridor file, haven't switched over to the super file yet. Actually, no, there's nothing really I need to do at this point. Yes, I guess there is. What did I just do? I updated my template library. But that template is not part of this corridor, right? So, being as I made the update at that location, I'm going to drop down to that template, and I'm going to resync with the library. Okay, so now my template is completely up to date with that change I just made as it pertains to superelevation. Okay, next I want to jump over into the super elevation file. Actually, I'm going to have to pause this for 1 second because the dog's going crazy. Okay, I'm back. Just had to pause that for 1 second. Anyway, let's see, where were we here? Yeah, we are sitting in the corridor file. And we went to our template drop and we click synchronize library. So now our corridor is up to date. And so now we are ready to jump into our super elevation design file. I'm just going to browse to the super file. And in this file, we're going to need to reference in two files, actually. I just referenced them in. They are the alignment and the corridor. You may not see this one yet, this 3D super, but once you create the super elevation, then like everything else, you end up with a 3D model. So in any case, go ahead and attach corridor and alignment. And so now the way that we go about first calculating our super elevation and our transitions, we go to the corridors tab, we go to create super elevation sections first. We give it a name. I'll just go with this default minimum tangent length. Let's see. The super elevation section itself is going to have a name by default SE. That's fine. And then we're going to locate the corridor. And then here, if you're we are working in the IDOT environment, and so they've got this set up to point to their rules file. But if you want something different, you can change. And this includes both the XML files that have the super elevation information for it. It has the IDOT tables, and that would be the design and environment tables. The local roads tables are just like slightly different, but they both come from AASHTO and are just very slightly different. So it's probably not going to make a huge difference if you use the AASHTO or if you use the tables. But in any case, you may want to decide, actually, in most cases, if you're doing IDOT work, you probably want to use their tables. And so really, it would depend. If you're working on a state job, typically, their super max is 6, unless it's like say an interstate ramp, which would be 8, or special situations, or if it's urban, it would be 4, for example. In this case, it's a county highway, so the county highways typically use 8, but at a 50-mile design speed, 6 might be appropriate also, but I'll go ahead and just use 8 in this case. And then you decide on that E selection, do you want to go with that 8% max table or this AASHTO method 5? I'll go ahead and stick with IDOT's 8 max table. On the L selection, I'll use their speed table. You need to know what your design speed is, and hopefully you would know by this point. This particular job used a 50 mile per hour design speed, so I'll go ahead and select that. And then being as I filled out all the information in the dialog, I end up just data pointing throughout, and then I assign that information to the corridor. Okay, so now if I click on the super elevation section, we're going to see a few things, and you can actually, basically in ORD, anything that's orange, you can actually change it here and it'll change throughout. That would be one option, but you can see where the transition begins. Right there is normal crown 2%. And then you got your beginning and end of your super elevation runoff, and what's the other one called? Tangent runoff. So that's at 0, and then probably that's your PC of the curve. No, it just shows where I guess you end up with a 2%. Your crown is removed, so to speak, and then you see your full super. Or other ways that you could visualize with the solution it came up with here. We could go to the super elevation editor, or the one I like to do is just to hover over the super elevation section. And there's something in here called, let's see, yeah, open your super elevation model. And I like that because it shows it graphically, and it makes sense to me. Okay, so I'm just going to pick a view, data point inside that view, and I end up with something that looks like this, which should be familiar to you anyway. This is sometimes actually even in the construction plans. There's a detail that shows this. I think it might even be in the construction manual, basically the same thing. But this is kind of graphically how they show, super elevation development. And so if I hover over the one side, which let's see, that would be the right side, because on the right, let's see, we're turning left, right? So the super's coming up on the right side. So you see the development there as, the very first thing that happens in the development of super is that your high side, your right side, starts to transition up, and then as soon as the crown is removed, and so that's at this point 2%, then you can see the left side over here. Now both sides, both lanes are pivoting about the center line, and then you achieve full super based on the 8% table with 5.8. And I know that you get a different result if I would use a 6% table, because now that I was just looking at that real life project I put out, and I think the super elevation that was calculated was 4.79, and so that's actually based on the 6% table, which is fine, but just so that you know that, I guess, that you do get a different result if you choose a different Supermax table. And so from here, if you happen to have like a design exception or something like that, where you want to distribute your super elevation transition differently than the standard here, I think you can go up to, like, maybe even without a design exception. Don't quote me on that, but you can go, up to, you have to read your manual. Depending, again, is it a local roads project? Is it state route? Then you want to be in the design manual and see if, for various reasons, if you have two curves close to each other, or like I just had a project where the curve is like was within like 60 feet of a bridge, and so I got a design exception to shorten the transition and to go with a 50% on the curve, 50% off, and I was able to do that by getting a design exception to shorten that transition length. But if that's the case, you can just come in here and make your manual changes to, whatever it is. Actually, you can make changes multiple locations. Let's see, yeah, I can make the change here. I can open up that super elevation editor that we talked about, and you can make it there. You could actually go to the plan view file itself, change it here. You get the same result. Wherever you're most comfortable working and makes sense to you, that might be where you want to make changes to the transitions if you're going with something that's not standard. Okay. So that's it. We've got, what we did right there is we've calculated super elevation, the Emax. We calculate our transition. It puts these nice, what looks like when we use geopack shapes, but this works differently. We're going to be applying these super elevation sections, and the outside, the purple, is the section. So we're going to apply that purple section to the corridor. So that's the end of this chapter. In the next chapter, we will apply the super elevation. We only calculated super elevation and the transition in this chapter.